Okay, in this lecture, we are going to talk about the cross-site request forgery. So, what is cross-site request forgery? We must first talk about the cross-site requests. When a page from a website sends a HTTP request back to the website, it's called the same-site request. So basically, same-site request comes from the same web server. You have a web server, it sends some page to the user. When user say click some button on this page, it will send back a request to the web server. This is called a same-site request. They come from the same site. If a request is sent to a different website, this is called a cross-site request. Because where the page comes from and where the request goes are different. A typical example will be, say, google.com. When you type in some keyword to search some web page, so that Google will search its database and then return the result. When you click a link on this page, it will actually be redirected to a third-party website. Then this request will come from the google.com, but it goes to a different website, say a.com. So this is called a cross-site request. Okay, another example here, if a web page, not Facebook, include a Facebook link. So when you click on this link, HTTP request is sent to Facebook. So you probably are familiar with this logo, the Facebook like button. This is actually a huge privacy concern. Okay, it's a huge privacy concern. Think about this. You visit a number of websites, say a.com, b.com, then z.com. So all those websites has this Facebook like button. So when your web browser loads this like button, right, it's going to send the cookie. The cookie will be sent to the Facebook. So now, every time when you visit all those websites, your browser is going to send a cookie to Facebook. Now the Facebook knows which website you have visited. In some cases, which link you have visited. Okay, so this is especially true if you have logged into the Facebook.com. This will link all this activity to your account. Even if you don't use Facebook, so Facebook may maintain an account, not an official account, but an invisible account for all your activities across the internet. Okay, so for the advertisement purposes, right? It's actually very common these days. If you say visit some website to search for some product, so next time when you visit google.com, the same category of product will be advertised to you. Okay, this will be a big privacy concern. For example, if someone visits some website with some medical conditions, right? So now the Facebook and the advertisement, right? They know you probably or your family probably have this kind of condition. So it may create a huge problem if such information is linked to the insurance policies. Okay, So the cross-site requests, so the cookie is sent to a site regardless where the request originates. So we have sort of touched this when we talk about this problem with the ubiquitous Facebook like button, right? So there are other buttons like Twitter. They all have a similar kind of link to be embedded in others' website. Okay, for same site cross-site requests, the browser will attach the cookies. So the vulnerable server cannot distinguish between the same site and the cross-site requests. So this is the vulnerability we call the cross-site request forgery. So it's possible for a third-party website to forge our requests that are exactly the same as the same site requests. This is because the browser or the server couldn't distinguish between the same site or cross-site requests. So where the request comes from, right? So if it comes from the server itself, it should trust the request to honor the request. If it's come from a third-party website, right? So it will be a vulnerability to honor that. So this is called a cross-site request forgery. So again, as we have mentioned, in many cases, website use cookie-based authentication, right? So you don't want to ask the user to type in their username and password every time they log in into your website. So to solve this problem, usually you use cookies, okay? So the browser or the user will provide the login information to the server. Then the server, after talk to the authentication server, okay, this will be the web server. So here will be our authentication server. So the authentication server say, okay, this is a legitimate user. Then the web server will send a authenticator cookie to the browser. Then the browser will save this in its database for this website. Next time when you visit the same website, so the browser will send this authentication cookie to the web server. Then the web server will talk to the authentication server, so whether this user has logged in or not. So the cookie can be used for authentication purpose, right? So here is a basic picture of cross-site request forgery. Okay, so the user establish a session with the server, right? It means the cookies are being exchanged between the user and the server. Okay, when the user visits a attack server, it will receive a malicious page. Okay, now, so the malicious page will send a request to the vulnerable server. Okay, it will send a forged request to the vulnerable server. So the browser, being very helpful, will attach the cookies to this request. Now the server will actually fulfill the request if it's vulnerable, right? So here is a question for you. How long do you stay logged in into Gmail, your Facebook, right? I believe it's a long time, okay? So here is an example with cookies, right? The user logging into bank.com, so the session cookie will remain in the browser state. So when user visits another site which contains the following HTML code, okay? So this is a form. So the form will, here, this part is a form. Okay, so the form is, say an input. You can type into data. So here, the action is a URL when you click or submit a form. So the the request will be sent to this URL, right? So here is using bank.com to pay some bills. So which bill you want to pay, and what's the value for this this field, right? So the recipient send this to which one? Okay. So here this will be a short sequence of JavaScript. So document F submit. So the F is the form here. Document is the DOM, document object model of this web page. F submit, say submitted this form. When this JavaScript is executed, right? So the browser will send this request to this URL as marked by action, okay, along with the authentication cookie. So the transaction will be fulfilled. So this is a cross-site request forgery vulnerability. Now here is a more detailed look at the example here. So here is the victim browser. So the browser itself, right, is not vulnerable. It's not compromised. So the browser here, in this case, is secure. So the cross-site request forgery, it's a vulnerability in the server. It's not a vulnerability in the browser, right? So make sure you understand this. So the browser is actually doing its own, its job, right? So it is supposed to send the cookie to the server. Okay, so there is no vulnerability in the browser to be exploited in this scenario. Okay, so the cross-site request forgery is a vulnerability in the server. It's not a vulnerability in the browser. Okay, so victim browser say, okay, get access the attack server, right? So the attack server will have this form on the browser, but at the same time it has this script. Okay, so the browser can, so the attacker can just create an iframe and put this piece of code in this iframe. So when the victim's browser try to open this page, it will automatically load this this iframe which will submit the request, right? So the bank.com and transfer, this will be the action, right? So this will be a method will be post. We have mentioned in the last lecture, we have a post and a get. Those two methods to submit a form, all right, to submit a request. So the target will be an invisible frame, okay? So the input, you have a recipient, and the value is attacker, amount is $100. Then this will be the form. So here you have this script to automatically submit this form. Okay, you don't have to click it. So the user, the user will not even aware the existence of this piece of code, right? So because iframe can be hidden. So when you have a hidden iframe, right? So sometimes it's just a single pixel. Okay. So the user doesn't even know this request has been sent to their vulnerable bank.com. Okay. So when this is loaded by the browser, so it will send this request, okay, and to the bank.com along with its cookies. Okay, so the server, because it's vulnerable, it's going to honor this request. So if you pay attention to the request being sent here, you see there is something called a referrer. So the referrer basically says the source of this request. Okay, so if you look at this, right, so because we assume the victim's browser is safe, is secure here, so the attacker will actually be revealed by the referral header. Right, so because this request clearly is not come from bank.com. Instead, it comes from attack.com. Okay. So again, so the vulnerable server will ignore this referral here. So this will be one of the defense mechanisms to prevent a cross-site request forgery. So here is another example without cookies, right? So you don't need cookies. So this will be the home router example. Right? So there are a lot of vulnerable home routers on the internet. Okay, so in many cases, a normal user will get a router from the service provider and put it in their closet and never change their password, right? So never do anything. So there are a lot of routers on the internet which are vulnerable to all kinds of attacks. Okay, so if you think about this, the router is actually fairly powerful, right? So it has, normally your router runs the Linux operating system. Okay, so it has in some cases it has 512 megabyte of memory, sometimes 1 gigabyte of memory, and also a fairly powerful processors. Okay, so the home router has been used in the distributed denial of service attack, which brought down the DNS system. Okay, so in this example, right? So you can, when you visit our bad website, it can receive some malicious pages. So the malicious page can send the forged request to home router. So one thing about the home router or this kind of attack is because the send-only access is sufficient to reprogram the router. Okay, so sometimes because those routers are incredibly vulnerable, right? So you don't even need to provide a username or password, or they are going to use the default password. Okay, so you can just say in the first request to log in with the default password or no password. Okay, then in the second request, you can just send the request to reconfigure the router. So this is actually very true. Like 50% of the home user have broadband routers with a default or no password. Okay, this will make the router to be very vulnerable. So here is the attack we are talking about. So when the user visits a malicious site, so the JavaScript at the site can scan the home network looking for broadband routers. So the SOP, so the SPOP is the same origin policy. Right? So the same origin policy prevents the website from different origins to interact with each other. Okay, so the same origin policy will allow the send only messages. You can only send the message. You cannot get the reply back. Okay, so you can detect whether it's succeeded or not using some trick, like you can try to load an image, right? Then in the own error, you can do something. So think about this, right? If you have a router on 192.168.0.1 or $1, okay? But here we only test the $0, $1. So this request will try to load an image from this location. So if the the router is there, right, and it is vulnerable, it will return an error immediately. Okay, it will return a so if the router doesn't exist, or okay, if there is no router, so this request, this image request, will time out. When you time out a request, it will take much longer than when the router actively return an error, right? So by using this kind of timing differences, you can tell whether 192.168.0.1 is is vulnerable or not, or even it exists or not, right? So once you found a vulnerable router, you can log into the router and change the DNS server. So when you change the DNS server, okay, when you control the DNS of the router, you can actually reroute any request you want to your to your attack server, right? So for example, if you can control the DNS request, okay, you can say if they access say bank.com, you can change the DNS response and redirect it to a attack server. So the integrity of the DNS server is very important, right? Because it will map the name to the IP address. So if the attacker is controlling your DNS server, okay, so it can actually say, redirect anything to something under their control. Right? So you don't want to, change your DNS server to arbitrary values, right? So you can. So one of the popular choice will be 8.8.8. This is the Google DNS. Okay. Then we have 1.1.1.1. This will be the DNS server provided by Cloudflare. Okay. I think there is also 9.9.9. So this is provided by IBM. Okay, these are the popular choices for public DNS server. Of course, your service provider will also provide the DNS server. In some cases, you don't want to use the DNS server from ISP because this will be a privacy concern, right? But of course, whenever you use any DNS server, it could be a privacy concern. So you can choose Cloudflare server, right? So if you are not comfortable with Google. So in the most recent Chrome browser, and all those browsers based on the Chrome, you can actually do a secure DNS. So it's actually based on something called a DNS over HTTPS. Okay, so the normally DNS is sent in UDP, right, in plain text. But here, you can actually use DNS over HTTPS to send a request to say google.com, right? So not google.com, say Google DNS or Cloudflare DNS. They all support this new feature. So by doing so, your service provider cannot sniff on which side you are requesting. Okay. So here is another form of cross-site request forgery. So in this case, so the server is vulnerable to logging in cross-site request forgery. So basically, the attacker can log in their account into this server, okay, on the victim's website, victim's browser. Say, let's say a user A visit some attack's website, right? So the attack's website will use this form to log in into say Google account, okay, with their username and the password, okay. So then the server will send a session cookie to authenticate the user. Think about what they can do with this kind of attack. Right? For one, if we're talking about say Google.com, right? So we know the user or the if you are using say Chrome browser, right? So all the website you visited with Chrome is actually saved into your Google account, logging into the server, logging into your browser. Okay, so when you're logging into the attack's account on the user A's browser, right, all the URLs visited by the user A will be saved in the attack's Google account. Now the attacker can look into those URLs, right? So this is another type of login cross-site request forgery. So the true story, PayPal was actually vulnerable to login cross-site request forgery. Of course, this was a long time ago, right? So the attacker can actually log into the attacker's PayPal account. Okay, when user try to use PayPal, so it's going to need to save the credit card information. Credit card information to the attack's PayPal account. Okay, look at this example, right? So the attacker logging into his PayPal account into the victim's browser. Now, when the victim try to buy something and pay for it using PayPal, it's going to save the credit card information in the PayPal's account. He thought it's his own account, but it's actually the attack's account. Now the attacker has access to the victim's credit card information. Okay, so of course it has been fixed for a long time. So next, let's talk about the CSRF lab. This will be fifth project you're going to do. So let's talk about the environment setup. We're going to talk about the target website and a victim user who has active sessions on the target website, and also a malicious website controlled by the attacker. Okay, so the attacker will craft a web page that can forge a cross-site request to be sent to the target website. So the attacker needs to attract the victim user to visit the malicious site. So the victim is logging into the targeted website, right? So when this happens, so the attacker can send a request to the vulnerable website. So in this lab, we're going to use ELGG. This will be the open source web application for social networking. Okay, so the ELGG actually has countermeasures for cross-site request forgery, but it's disabled in your lab. So this will be the target website. This will be the attack website. So both of the sites is actually being resolved to your local host. So you're actually accessing your local VM. Okay, so using the using the DNS, right? So you can redirect those sites to your local computer. Okay, they are hosted on the local host by the Apache's virtual hosting. Okay, so if you are curious where are those documents or the web page, this will be the document root for the attacker. This will be the document root for the ELGG web service. Okay. So the HTTP GET request. So the data are attached to the URL. We have talked about this for the HTTP GET request. So the data attached to the URL using the key value pair, right? So this will be the key, this will be the value, this will be the key, this will be the value, right? So the HTTP post request data are placed inside of the data field of HTTP request. So here, you see here, this is the GET request, this is the post request. So they both have this URLs, okay? So for the HTTP post request, so this will be the data field of the HTTP request, right? So for the HTTP GET request, it's a part of the URL. For the HTTP post request, it's a part of the HTTP header. So the CSRF attack on the GET request, here is the basic idea. So consider a vulnerable online banking application, right? It allows the user to transfer money from their account to other person's account. So a user is logged in and has a session cookie, which uniquely identifies the authenticated user, right? Because it's vulnerable, right? So the vulnerable server will only do the authentication based on the session cookie. So the HTTP request to transfer $500 from his or her account to account 3 to 3220 is appears to be this. So you have the site, the scheme, right? HTTP. We have site. So this will be the which function or which page on the server, right? So we're talking about the transfer function, right? So the PHP is a programming language, okay? So from to this account, so the key is to, value is this account number, so the key amount, and this will be the value. So the attacker needs to send out the forged request from victim's machine so that the browser will attach the victim session cookies with the request. Okay, this is very important, right? So you need to trigger the the victim to visit the attack's website. When the attack server return a page to the victim's browser, it's actually running in the context of the victim's machine. So the victim's browser actually will attach the victim's session cookies with the request. So we can place the piece of code in the JavaScript to in the attack's web page, right? So to trigger the request. Okay. So HTML tag like image or iframe can trigger the GET request to URL specified in the SRC attribute. Here are two different ways, right? You can do an image, right? So it's very easy to hide an image, right? Just to make it to be, one by one, right? Just a single pixel. So this will be the when you load this tag, so the URL points to by SRC will be accessed by the will be executed by the browser. Okay, for the iframe, this will be very similar. Okay. Okay, so here is the your task will be attacking on the ELGG's add friend service, right? Add yourself to the victim's friend list without his or her consent. So before you can launch the attack, right? So you need to know, how is the request being formed, right? How can you create a legitimate looking request? So then you need to do some investigation. So the normal way to do investigation, like for example, right, for Facebook.com. So a legitimate or ethical way to do the investigation is to create account A and account B on the same server. Okay, then you can do all kinds of experiments between those two accounts. You can add them as friends, you can delete them as friends, you can put some message. Okay, so then during this process, you can look at what kind of data is exchanged by using, for example, like a Firefox Nav HTTP header extension to capture the request. So here is very similar. We can create a test account under your control, right? So in this account, you can add somebody to to his friend list. Then you can use the Firefox Nav HTTP header extension to capture the request. Now, by looking at the capture request, you know how to combine this information to create a request, right? So here is the captured HTTP header. So in line 1 will be the URL of the ELGG's add friend request. Okay, so this will be the URL of this add friend request. Then it has a number of parameters. Okay, so the 42 will be the user's ID. So for each user, it has an ID. It's pretty easy to get the user ID if you look at the look at the public page of this user. Okay, so for the 9.2 and the 3, for the 9.2, it's the countermeasure against the cross-site request forgery attack, which are disabled in our VM. So we're going to talk about this. This is actually token-based or secret-based protection against cross-site request forgery. Okay, so we're going to talk about this later. So in 9.3, it will be the session cookies. Here, this will be the session cookies which identify this user, right? This will be automatically sent to the server. So all the other part of this part will be HTTP header automatically generated by the browser. If you look at this header, right? So here we see a referral, right? So we're actually looking at the Sammy's profile. Okay. So now we can create a malicious web page using an image tag. So this will be the source. When you when the victim browser loading this this piece of HTML. So it's going to send the request to this URL, right? So it will say friend add friend 42, okay? So if you look at this, right, so the image has a width of 1 and a height of 1, right? So this will be very difficult to the victim to spot this image tag. So the craft web page is placed on the malicious website here. Okay. So now we need to attract the victim to visit your malicious page. So the SAMI can send a private message to Alice with the link to the malicious web page. Right. So this is called a phishing attack. So the phishing attack is actually incredibly effective, especially if if the attack is targeting some big corporations like. We all know what happened to Sony. Right? It was compromised through the phishing attack first. Okay? There are other ways like ads or the stored pages. So, for example, somebody is going to visit open a forum, right? So there are a lot of forum on the website. Okay, so if this website are vulnerable to to fill out those special characters, okay, so they can create a stored cross-site request forgery. Okay, they can be misused by the attacker. So if Alice clicks link, SAMI's malicious web page will be loaded into Alice's browser, and a forged add friend request will be sent to the ELGG server. So on success, SAMI will be added to the Alice's friend list. Okay. So the CSRF attack on the HTTP post service. This is actually very similar, right? So you need to understand the what's the URL to use, right? By using the investigation method we mentioned before. Especially, you can create 2 accounts and perform the action and capture the exchange, right? So the post request can be generated using HTML forms. Okay, so here the above form has 2 text fields. A text field is marked by input. Okay, so we have 2 fields here. One is the receiving account. The second is amount, right? So we have 2 fields here. Then we have input. The type will be submit. So here, if you look at the web page, the generated website, right? So it will create a button, say submit. Okay. When the user click on the submit button, so the post request will be sent to the URL specified in the action field. This will be the URL the browser will send when you click the submit button. Okay, so the attack job is to click on the button without the help of the user. So here will be an example. This is a piece of JavaScript. It will automatically generate a form. So as we have mentioned, right? So you can use a DOM, or document object model, with JavaScript to dynamically create a part of the web page. Okay, so here we actually create a form, right, with this action and with those 2 fields. Okay, so then this will be a post. After this, you can add this part to the body. Body will be, let's look at one of the here. Okay, So the body will be the DOM's representation to this part of your HTML page. Okay. So this will be a document.body.append child. P is the form. So you're actually adding this form to the body of the HTML page. Then you call this function p.submit. You actually submitted the page directly. So okay, so the whole attack is actually a piece of JavaScript, right? So you can see JavaScript is actually hugely powerful to manipulate the web page, right? A window unload equal to a function this. This will actually sign the event. So unload is an event. When you load the web page, it will be automatically triggered, and it will call this function post function. Then it will send the the request to the server. Okay, so here, if you look at this, right, this is actually assign the unload to a forge request. This will be actually be a function. Okay, so let's not talk about this in details, right? So, but it's just a part of the JavaScript. So here is the attack on ELGG's edit profile service. So the edit profile, usually this will be submitted in a post request, right? As compared to, say, add a friend. Add a friend is pretty simple. So you can use a HTTP GET request, okay? But for edit profile, right, because there are so many different things you can edit, so normally it's you're going to have a list of forms, right, a list of inputs. Then at the bottom you can have a submit. Okay, so normally edit profile kind of complex request are generated using a HTTP post request. Okay, you can put a statement, Sammy is my hero, in the victim's profile. So you can do the same kind of investigation by editing your own edit profile request and using a nav HTTP header to catch a request. Here is the URL, the exchange we captured. This will be the URL of the edit profile service. For number 2, this will be the session cookies, right? For each user, you have a unique session cookies. Then number 3, again, this is the cross-site request forgery countermeasure, which are disabled in your server. Okay, so later we have all those different parameters, like name is Sammy, description is Sammy is my hero. Then it has this access levels. Okay, so the 2 means visible by everyone. Then there is a user ID. So the user ID of the victim, this can be obtained by visiting the victim's profile page. Okay. Okay, if you think about this, right? So the GUID is not the when you do the edit, right? So the GUID should be the UID of the victim. So the UID of the victim, not Sammy, right? Because you want to edit the victim's profile, not Sammy's profile. Okay, make sure you use the ID of the victim, right? So, but you can by visiting victim's profile page. So here is the way to craft this malicious web page. We have HTTP header here. Then we have this function called forge post. It's very much like similar to the the one we talk about this in this page. Okay. So we have a number of fields, right? A hidden name will be Alice, and description. Sammy is my hero. Then access level will be 2, and also GUID will be 39. So the 39 will be the GUID of Alice, right? Okay. So like here, if you look at this page, right? So the name is Sammy, GUID is 42. This is because we're doing the investigation. We're looking at Sammy's edit profile service, right? So we actually try this out on the Sammy's own account. So the attack's name is Sammy in this lab, right? So we're looking at Sammy's own account. We try to edit its own profile, and we look at the request. So this will be a name equal to Sammy, and the GUID will be 42. But here in this attack page, we need to use the name of Alice, and the GUID will be 39. Of course, in your project, you need to find out those values, right, by your own. Okay, then we create a form. So this is the form's action. Then we have these fields attached to this form, right? So the form, the method is post. When we append this to the body. So the body is a DOM representation of this part of the HTML page. Right? So we append our child. Then we call the psubmit. Okay. So again, on the Windows Unload, we make it this is the code. This is called closure. Okay, you cannot say Windows.unload equal to a forge post. So you cannot do this, because when JavaScript, try to interpret this line of code, it will actually execute the forge post. But at that time, so the DOM, okay, so this will actually lead to some errors, because maybe the document hasn't been created yet, right? So this is why we need to use this form. Okay, so we basically define a function which will call the forge request. Okay, so this will be something called a closure. If you are interested, you can read about it in the JavaScript. So again, the point is that you cannot use this, because when the browser tries to look at the run this line here, right? It's going to execute the forge post function. But at that time, so the window hasn't been loaded yet. So the DOM model has not been created yet. So when you try to execute this, it's actually going to return an error here. Okay. So, but it's fine to reference this when you define a function. So here will be define a function, but the function, the main body of the function will not be executed until you call a function. Okay. So that's totally fine to define a function, but it's not fine to execute it, right, until the window has been loaded and the document or DOM has been created. Okay, next let's talk about countermeasures. So the fundamental cause of the cross-site request forgery is that the server couldn't distinguish between whether the request is a cross-site or same-site. If it's same-site, it can be trusted. If it's cross-site, you should not trust this. Okay? But obviously, so the browser knows the difference, right? So because when you send the request, right? So the browser knows, where this request is come from. Okay? So the browser knows which page our request is generated. So the browser can help the server to defend against the cross-site request forgery. So for one, you can use referral headers and also the same-site cookies or the secret token. Right? So the server will help itself to defend against cross-site request forgery with secret token. But normally you should combine those different measures to make it more secure. So countermeasures, the referral header. So when the browser sends a request, it will automatically add something called a referral in the header. We have looked at this in the previous slide. Okay. So this field will reveal part of the browser history, right? Because you say where this request comes from. So sometimes it can cause privacy concerns. Okay. So this field sometimes is removed from the header. So think about the case, right? So if we are doing, if we have a internet, or the internet is a fancy word for the the internal network. So on the internal network, you maintain some pages, right, which refer to a public page on the internet. Okay, so here this will be your router. Sometimes it's called a gateway, right? Okay, so if this happens, right, so the URL on the internet or the internal network, which refer to a public site, will be sent to the internet server. Now, the server has a URL of the internal network. So sometimes this will leak sensitive information. Okay, so the gateway or the router may remove the referral header. Okay, so referral-based defense is actually not very, it's not completely secure. Okay. So here is an example, right? So we have talked about this before. When the victim browser tried to visit attack.com, and the attack.com try to log the attack into the google.com on the victim's browser. So the server can look at this request, especially this field in the header, the referral, so this request comes from attack.com. So we should reject this, right? So because this is different from google.com, so we can reject this request because it comes from external source or third-party request, right? So referral header can be very helpful in defend against the cross-site request forgery. So the second kind of measure is called same-site cookies. So using a special attribute to cookies called same-site, right? So this attribute is set by the server. So we'll say, okay, we need to return the authentication cookie to the browser. So it tells the browser only attach this cookie for the same-site request. If it's a cross-site request, don't attach this cookie, right? So this is basically, the meaning of this same-site request. Assume the browser is not compromised and it follows this specification. We can make sure, the cookie will only be attached to the same-site request. Okay, but this defense is not very effective against the logging. It's not effective against logging cross-site requests forgery, right? It's not very effective in this case because at the beginning there is no cookie exchange. Okay. So this is why same-site cookie is not a complete defense. So normally you should use a secret token. So the server will embed a random secret value inside each web page. Okay, so basically when the server create a page for the user, right, it's going to embed some secret numbers in this page. Every time you visit this page again, it will be a different secret value. Okay, and the secret value is of course very hard to guess, right? So when the request is initiated from the same-site page, a secret value is included with the request. So the server can check this value to see whether a request is cross-site or not. Okay, page from a different origin will not be able to access the secret value. This is guaranteed by the browser's same origin policy. So the same origin policy basically enforces the isolation between two websites with different origins, right? So if we look at this, right, this will be attack.com, this will be bank.com. So attack.com cannot say, look into the web page of bank.com and to retrieve the secret number or secret token here. Okay, so the attack.com will not know the secrets. Okay, so all the requests sent by attack.com will not have this secret token, and then the bank.com can reject those requests. Right, so the secret is randomly generated and is different for different users. So there is no way for attacker to guess or find out this secret. So here it's very important that we substitute the unguessability for unforgeability. This is actually two different concepts, right? So the first one, it means that the attacker cannot guess the number or guess the secret. So the second means the attacker cannot forge the secret. Okay, cannot figure out in some way of the secret, right? So here we actually have unguessability, but it's very difficult to guess right? So it's actually a pretty good substitution for unforgeability. So here we have an example. If you look at this, right? So this page has a hidden form called input name will be authentication cookie, type will be hidden, and the value, this will be the secret value. Usually, this will be the hash of some secret items. If you look at this, right, so when the user click this add slice button, okay, so because this is a hidden input, when the user try to submit this form, right, to post this form, so this part will actually be attached to the post request. So the server can look at this, authentication token and validate its value. Okay. So basically, when you log into this server and you try to create this request, so the server will, because it's the same side request, the server will embed this special inputs into this form. When the user click add slice, submit this form, this field will be submitted to the server as well. So it comes from the server and be returned to the server. So the server can validate this. Right? In the ELGG's countermeasure, it's actually used the secret token approach. Okay. So the secret token, it's a hash or the MD digest or MD5 hash, right? So the MD5, you should not use MD5 nowadays, right? So you should use a more secure hash function. But at that time, it's MD5. So it's the hash of the 4 pieces of information: the site secret value, the timestamp, the user session ID, and the randomly generated session strings, right? So if we can guarantee the random number used to in this generation of the session string, we can make the hash to be very difficult to guess, right? Okay, so this is the cross-site request forgery. Let's stop here.